Welcome everybody to our next lecture regarding the feedforward control. In this lecture we want to talk about feedback plus feedforward. So if you remember the last video you probably saw, you might remember that we have a system, a chemical process with input variables, output variables and disturbances, and that we are measuring the disturbances when they are entering the system, and then we are feeding them forward to our input so that we can react to the disturbances before they are upsetting our outputs. Now we want to combine the two concepts of feedforward together with the approach of feedback. So not only are we measuring the disturbances and feeding them forward, but we are also measuring the output variables, and we are introducing feedback again. So here we have our feedback. Here in the lower part you can see how the abstract view of such combined system of feedforward and feedback looks. Here in green we have our core process. So here we have our process with our transfer function GP, our disturbances ds with our transfer function ds, our output ys, and over here you can see the feedforward part, so in reddish color. And here we have a sensor which is measuring the disturbances. So we are introducing a GM for measurement 2, because we have two sensors, GM2 from S. And the values the sensor measure are then forwarded to the feedforward controller with its transfer function GFF from S. And we have the set point, which we are transforming by the transfer function GSP for a set point. Our input SP, so this is the set point we want to have for our process. So, and we are also measuring now our output in order to create the feedback loop we have over here. And this feedback loop is also built out of a sensor which has the transfer function GM for measurement, number 1 from S. And now we have here two loops. On the top we have the feedforward loop with the feedforward control, and on the lower part we have the feedback control which measures the output and feeds it back to the input of the system. What can we see here, or what should we know about such a feedback feedforward control? The first thing we should know is that in this combination we have the potential to create perfect control. So potential to realize perfect control. What does that mean? It means that, for example, if we have some kind of disturbance, we are measuring it before it even enters the system, we are correcting for it, and then even if we still have some kind of minor disturbances of our outputs left, we are also measuring this again and then adjusting our inputs accordingly. So in theory, if everything is known about the system, we have the potential to create a perfect control system so that our output value ys is always equal to our set point ysp from S. But as you may imagine, we are dealing as engineers with the real world, and therefore it's quite tough to realize that, because in order to determine these values for the feedforward control or for the transfer function of the disturbances, so the GFF and the GD, we have to know all the disturbances, and we have to be able to measure all of the disturbances. Because if we have some kind of disturbance here, which is not measurable output, not measurable disturbance, then we also can't feed forward them. So therefore here you have the split between the measured and the unmeasured variables, because we can only use in the feed forward part what we are also able to measure. So all the unmeasured disturbances are disturbances we have to deal with in our feedback part, because these unmeasured disturbances will upset our output variables. But then we have to deal with them in the feedback, and so therefore maybe our control will not be as perfect as it would be if we could measure all the disturbances. So what we should know is that in order to realize such perfect control, we require all the disturbances. So we should write down that it requires the identification of all possible disturbances. And as you can imagine, therefore I underlined also the all, because all possible disturbances which could happen at any time in the future, to determine this set of disturbances is really, really tough. And oftentimes in the real world, it's not possible. So here we can note that it's often not possible. So what else should we know about the system? One other aspect is that in order to work with this kind of system, we have to be sure, for example, that our process itself is not changing. So in order to have a good feed-forward control, we have to ensure that our GP, so our process here, is really well known. Therefore, parameter changes in our process itself cannot be compensated if we are just using feed forward, and together with feedback, we then can compensate again for it. So we can write down that for feed forward, the process itself must be known. So the process parameters have to be known. And if you're just using feed forward, they have to be known because we can't react if they are changing. So we can't compensate for change in the process. So in feedforward, the process parameters have to be known, and we can't compensate for parameter changes. Why can't we compensate for parameter changes? Because if we are just using feedforward, we are not measuring what happens after the process, so we don't have the feedback. Therefore, we have to rely on our models which describe our process, and we can compensate for this problem when we are adding back the feedback, like we did here, because then if the state variables of the chemical process change in a way which our model is not predicting, then it's not a big issue if we are able to measure our output, because then we can feedback the changed variables and adjust our inputs accordingly. So we can write down here that for feed back plus feed forward, so feed forward plus feedback, then we can compensate, which we can't do just with feed forward. So feedback plus feed forward can compensate. Can compensate for changes in GP, for example, or also GD. So it can compensate for changing GP from S or GD from S. Yes, what else should we know when we are thinking about this kind of system? Of course, we should know that when we are thinking about stability of systems, that it's always good to have it in mind what happens when I add, for example, feedback or feed forward to my system. Will the system still be stable or not stable? And here we can note that if I have a feedback part, so just the lower part of our image here, and I will then add the feed forward structure, so the upper part, then it will not change the stability of the system because because the feed forward part will just add information and will not upset the system in a way which creates instability. So we can note here that the stability of a feedback system will not change. Will not change with the addition of feed forward. Yes, with this overview of the combination of feed forward plus feedback, which enables us to compensate for changes within the process in comparison to just the feed forward, which is not able to compensate for changes within the process itself. With this overview, I want to thank you for watching this video and see you in the next one.